All right, so we're going to talk about decimal degree and degree minute second, or what you'll hear me call DMS, which is different than DMX, if you know who that is. Before we get started, just want to see how much random knowledge you guys have. Do you know the reason why birds, ducks, a lot of times, flamingos, you can see, why do they stand on one leg sometimes? I know the reason why. Do you? If you can come up with an answer, I'd like to see if you're right. So come tell me. You're wondering why I thought about this? Don't even ask. It's not important. Okay, so let's get to it. Do your job, T. Okay, so we are going to practice converting angles from degrees, minutes, seconds to decimal form. So, we're very familiar, like you could say that an angle measure is 36 degrees, maybe it's 36.28 degrees, but instead of having it in decimal form, we could have it in terms of minutes and seconds even. So, we're not too concerned about you guys doing this by hand. It's more so how can we do it on the calculator. So here are just some directions in terms of the graphing calculator that you can use. So make sure you have your graphing calculator next to you. I'll go through this example with you. So how can we're converting from DMS to decimal degree form, and we're going to round our answer to 3 decimal places. So in your graphing calculator, you're going to type in 85. And we want degrees, so as it says in your notes, you're going to go to, see how the angle in blue here? So second angle, here's my degree symbol, press enter. 85 degrees. We have 18 minutes, so type in 18. Back to that same spot, so second angle, there's my minutes. And as it says in your notes, you get the seconds, which kind of looks like a quotation. Notice that it's here above the plus sign, but in green. So we're going to do alpha plus to get that. And then if we press enter, notice that it gives me the DMS in decimal degrees. So that's 85.308 degrees. I love when the calculator can do stuff. Okay, let's have you guys do number 2. So type it in as is and then convert it to decimal degree form and round your answer to 3 decimal places. All right, so hopefully you got negative 125.01 degrees for this one. Here's my work on the calculator for that. Notice that you do have to put in 0 minutes for this one. So yes, I didn't warn you in advance, so maybe you got error right away. But you know. Okay. So this time we're going to go in the reverse direction. We're going to go from decimal degree to DMS. So in your calculator, you're going to type in this degree measure, and you're not going to put the degree sign like it says here. And then you're going to do second apps DMS, enter, enter, and then go from there. So I'll do the first one with you. So we have 642.54. If I go back to where it says the blue angle, notice that the fourth one down says DMS. I press enter, and notice that it just gave it to me in DMS form, decimal minute. All right, so let's have you guys try the next one on your own. All right, let's check your answers here. We got this one together before, so I had negative 46 degrees, 31 minutes, and 12 seconds. All right, now let's put this into a context of a problem. It's probably like, why are we doing this? This is all kids ask in math class. So let's put it into a context. So what we are going to do is we are going to find the distance between Johannesburg and Jerusalem. And like it says here, assume the Earth is a sphere of radius 6,738 kilometers, and the cities are on the same longitude. In other words, one city is due north of the other. I'm going to help you get started on this one, and then I'll have you finish. So it's always nice to draw a little diagram for ourselves, right? Right. So this really is an arc length problem. Let's imagine that this is that little chunk of the Earth. This is that equator here. Maybe I should write that down. Yellow, my eyes. Okay, that's the equator. You know, this down here, and this up here. Maybe I shouldn't draw that. Whatever. Here, you know, in one place we have South Africa, and one place we have Israel. Places we're looking at. So what we're trying to find is this arc length, which remember we use the variable s. Okay, so you know, we are going to need to use our central angle equation, which, by the way, is theta equals arc length over radius. Don't forget that this needs to be in radians, okay? And again, like I said, we want to figure out, well, what is this arc length? Okay, so let's see if what you guys can do. Try to figure that out. My advice where to start is figure out, well, what is this angle using this information? By the way, don't forget that, you know, we have to add, right? And then somehow you're going to have to use this and find s. Go ahead. Okay, so let's see what I did here. So I started by finding out, well, what is this angle here? What is this central angle? And I found that in terms of degrees, minutes, seconds, right? So I got 57 degrees, 54 minutes. However, notice that when I did plug that in for theta here, I needed to put that into radians, right? Which is why I multiplied it by pi over 180. We spent some time working on that before. So then I also had to multiply it by the radius. The radius, you know, would be this in the directions, right? And I solved. I got 6,809.057 kilometers. And if you're curious how I put that into my calculator, here's my work right here. I just plugged it in as is, all in one step, really.